Hello, I'm George Malin, the Managing Editor of Vanilla Plus, and welcome to today's webinar, the topic of which is how mobile operators can use machine learning to detect and optimize the network for roaming IoT devices. With IoT connection volumes finally starting to ramp up, telecoms operators are now seeing the first fruits of their efforts to provide connectivity to IoT and M2m devices. In fact, in future, almost half of roaming revenues are set to come from machine-to-machine communications and IoT devices. However, whilst this is vital and attractive revenue for operators struggling with the commoditization of their traditional offerings, providing permanent M2M and IoT roaming is seen as a key challenge by mobile operators. By gaining a complete view of the IoT devices roaming on their networks, mobile operators can optimize their networks for M2M traffic, offer optimal quality of service, and ultimately monetize IoT better. That's easily said, but harder to achieve, even though the information needed to unlock this potential is already present within an operator's network traffic. To make use of it, it needs to be mined and interpreted. To this end, BICS, one of the world's leading providers of roaming cellular connectivity, is putting forward a new tool called BICS SMART Webvision for advanced end-to-end traffic monitoring, reporting, and business intelligence that uses advanced analytics and machine learning techniques to provide the insights needed to optimize and improve the network for M2M roaming traffic. I'm delighted to welcome Damien Rose, a mobile signaling and roaming expert from BICS, who will discuss how mobile operators can use machine learning to automatically detect and optimize for roaming M2M devices. Before I hand over to Damien, I'll turn to the first question of today's audience polls to set the scene. Could we have the first poll on screen, please? So the first question is, what do you consider to be the most significant barrier to efficient monetization of M2M and IoT roaming? And the potential answers are there below. So if you vote, that would be great, and we'll discuss that shortly. While you're voting, I should point out that Damien has kindly agreed to stay on after his presentation to take questions from the audience. To participate in that, simply enter your question into the panel on your screen, and I'll put it to Damien after his presentation. So we'll wait for the voting to settle down a bit. Okay, Damien, I think the voting's settling down. Is this what you expected to see, Damien, in terms of most of, or the largest proportion of the audience, at least, going for the first response?
Actually, it's right in line with what my expectations were. Maybe there could have been a bit of a switch between the first and second answers, the lack of high-value use cases versus the lack of transparency. But the top three, the use case value, the transparency question between operators, and also the traction in individual markets are precisely what I thought would be the key issues.
Great, that's good to know. And I guess obviously the final answer, limited traction for M2M and roaming in your market, is still very much a fact given the relative immaturity of IoT roaming deployments at the moment. You would expect that to change, I guess, in future.
Exactly, and the answer to that question would also vary region to region. So depending on where you're from, that may be true or not. But I think when you're looking at it from a global perspective, we're still in the nascent stages of really ramping up the promise of machine-to-machine and IoT more specifically. So I think I would expect this to change in the short term, actually. I would say 2 to 5 years from now, this probably may no longer be an issue. It's going to be more about how do we handle the growth. But for today, it's still very sandbox in different regions.
Great, thank you, Damien. I guess now it's interesting to get that to set the scene. But let's move on now, and I'll hand over to you for your presentation. Damien, the floor is yours.
Thank you very much, George, and welcome to everyone to the webinar. Thanks a lot for joining. As George kindly explained, I'm going to be going through some of the potential benefits of applying advanced data science techniques to what is an already successful business model to extract that much more value from it, specifically in terms of machine-to-machine and IoT roaming devices. There's a very simple okay, hopefully everyone can hear me clearly. If not, just let us know in the chat, but I'm going to continue.
Damien, there was a bit of echo, but our technical team has cleared that up. There shouldn't be any more interruptions. Apologies for that.
No problem. It happens. Okay, so the structure of the presentation is kind of laid out. It's very simple. We're going to go through IoT and M2m in summary. So not delving into the detail and pernickety aspects of what this means, but how it applies in a realistic way to the world of mobile operators. We'll also go through a brief introduction of machine learning and also hopefully remove some of the fog in terms of how this is understood or interpreted. And then we go into some sample use cases, focusing on a very fundamental use case that most operators need to tackle, but then the subsequent use cases that are necessary or that may become very popular in terms of monetization strategy around M2m and IoT. So I'm going to move on to the first slide of today's presentation. And it's just to give a summary of the company that I work for, BICS. BICS is a global carrier services provider operating pretty much everywhere in the world you can think of. We're consistently one of the top 3 providers in terms of voice, SMS, data transport, and a range of other value-added services. As the slide demonstrates, I'm not going to go through each item one by one. Not only is there breadth to BICS in terms of the value creation that we do in the market, but we are one of the trusted partners for over 1,200 customers worldwide, again, across various services and technologies, SS7, LTE, and other forms. Most of you may be already familiar with BICS. We've been around for over 20 years, and year on year, we keep looking into the market to understand what our customers and potential customers' needs are and focus on the creation of value. And that's actually one of the guiding posts from our presentation today. How can we continue to create value for the various players in the mobile ecosystem? It starts with a quote that I hold very dear. It's by James Harrington, and it speaks to the value of measurement. It's a very fundamental concept, and most of you probably can appreciate it, but often we forget how important it is to be able to measure something. Because without the ability to measure, there's literally no way to improve, control, and I would add a further step, which is not mentioned on the slide here, monetize. If you don't know the size or dimensions of something and you essentially don't understand it, it's very difficult for you to then somehow use that to extract value from either people who require a service, for example, or players who need you to create value for them in order to build value together. So we're going to see this theme coming up several points in the presentation, the ability to actually measure the thing you want to monetize. Now, everyone should be somewhat familiar, I think, with the current state of play in mobile in general, but specifically the role of mobile operators in what is seen as the next wave of revenue-generating services for machines and devices in roaming. Now, for the past few years, mobile operators have focused a lot on the connectivity layer of this value scale or value pyramid. And I've taken an extract from the GSMA Intelligence's latest research piece that kind of just gives a forecast as to what's going to happen with the different players in terms of how much value they're extracting from the M2m and IoT market. And as you can see, globally the pie is increasing. So if you look at the actual dollar value for the blue points, which are specific to connectivity, and this is the area where mobile operators today really focus on, you'll see that although the total value is increasing from 25 billion in terms of revenues per year in 2018 to as much as 51 billion in 2025, the percentage as it relates to the entire value available in the M2m and IoT market is shrinking. So yes, there is essentially more money to be made on connectivity, but it's increasingly becoming a smaller and smaller piece of the overall pie. And the question is, how do the players at the connectivity level increase that slice, increase their share in terms of value capturing? And the simple answer is more value has to be injected. If you don't create more value at the level that you play at, it's very difficult for you to actually extract more value from the overall proposition. And this is a note that I think mobile operators need to keep in mind. Connectivity is extremely important. It, however, is seen by a lot of other players in M2m and IoT as a commodity. And unless something is done to radically shift the perception of the mobile network and the connectivity it provides, this is going to be a trend until the bottom. Now we're going to look at the roaming scenario, and we start now going into how the mobile operator actually plays a role in this. And this is where we actually start to understand why the value proposition needs to be reshaped. If you were to simplify M2m and IoT roaming, it would essentially boil down to a number of devices distributed across various networks with the sole purpose of gathering data that is going to be transported by some network to a system that makes use of it. And I've tried to summarize this on this slide. In fact, maybe it's good to make a few distinctions, because I keep using M2m or machine-to-machine and IoT interchangeably. And that is because in some sense, they are interchangeable. Now, if I were to define machine-to-machine, or what would you define as an M2m device? Essentially, it's going to be a very broad label that describes any technology that enables a network device to exchange information and perform actions without having to interface or interact with a human. Okay. Now, in the early stages, this had various connectivity options. So we're talking about serial cables, wireline connectivity. This has now evolved to wireless connectivity. And if you were to just abstract that, the IoT is essentially just a focus on the wireless aspect of M2m, because you could define an IoT device as any networked device or object that contains some technology to allow it to communicate or sense what's happening in its internal or external environment, and again communicate that with some system downstream. So it's really, for me, the two are not necessarily distinct. IoT is actually an advanced form of M2m, so I'll continue to use it interchangeably. Now, because at the core, the need for these devices is to actually provide the data that they're capturing to some user, and this user can be a system or a person, but to some user to actually process, extract useful information from what was previously unstructured data, and either make a decision or take a next action. The flow of the data is what is extremely important. And here we're talking about not just the volume of data that needs to flow, but also the reliability of the data, the frequency of the data, the security of the data. And within this data flow, and hopefully it's evident in the diagram we have here, the data transmission or the connectivity piece, which again is where the mobile operator focuses, is a key element to making the entire M2m and IoT roaming ecosystem work. And this is where I think we need to make the shift in terms of how we interpret the value proposition at the connectivity level, as opposed to just a dumb data pipe, to a key infrastructural resource that needs to be effectively monetized. And I'm going to go through how this works. Before I change the slide, though, there's another flow that we need to keep in mind, and the flow at the top, the flow of control. So if I were to just step a few sentences back, if we look at the blue arrow at the bottom of the diagram, you'll see that the flow of data originates with the devices in roaming, so the data gathering layer, and terminates at some user. Okay, so the data is generated by the devices, consumed by some user. Control starts at some user, and again, a user here can be a system, a person, or some other platform, and it terminates at the devices. And I'm bringing the flow of control into the conversation here because to properly monetize the role, or to properly and effectively extract as much value as you can from the connectivity or data transmission layer, it is important to understand that you have a role to play as well in the flow of control. And it's that layer that's going to be where the business models, I think, of the future for mobile operators evolve. Okay. We are going to move on to the next slide. Hopefully, everyone is still following so far. Now, the simple concept is stop looking at networks as just networks that provide connectivity to people, humans, people and things. What you are actually delivering is a highly valuable set of services. So we need to take the concept of the network as a service. Now, within this network as a service concept, there are different things that we offer, or we need to guarantee to the different users of our networks and the consumers of our network services. These include coverage, global coverage, and ubiquitous coverage is now a requirement for almost any application that requires a mobile network. Performance, and performance is often a talking point, not just in terms of what the networks are capable of, but what people and things are willing to tolerate. So providing a high-performing network, obviously at a cost that is acceptable to the consumers of network services, is also a requirement that we have to meet within the mobile industry. Security is a huge talking point for the last 5 years, especially with the range of signaling and data transport security issues that have popped up. It has underscored not just the need for security, but the value people place on security. And this value on security applies to machines as well. Network availability, we all work and strive endlessly to ensure maximum uptime for the various networks that we operate. A lot of time and resource goes into this, and it also is one of our core expenses to ensure that this happens. So the availability of networks, high performing and secure networks, is also a value proposition that needs to be considered when you're looking at the network as a service. This all lends itself to reliability, the prioritization of traffic passing over the network, and ultimately as well the transparency in terms of the performance of this network towards the people who consume the network services. Now, these are things we talk about as mobile operators, as carriers, as players within the mobile ecosystem on a day-to-day basis, and we see them as fundamental pieces of the day-to-day. But in terms of machine-to-machine roaming and the Internet of Things, these are actually core requirements to the desired outcome of the different solutions that are being pursued. Okay, so if we think about, for example, a few M2m and IoT use cases, we can talk about a car, for example. You may have a car that has several IoT applications running. It's connected for different reasons. You may have basic fleet management. You may have driver performance monitoring by insurance companies. You may have stolen car notifications that are sent out. You may have just the diagnostics as well from the engine and the other pieces of it. Now, all of these things are actually different use cases that may actually require different things from the network. Some may require more security, for example. Some may require more reliability, and we take into account here, for example, if your car is actually stolen or if there's an accident, you need to ensure that that alert gets to wherever it needs to get to. So the use case the use case determines which element of these day-to-day features of a mobile network are of highest value based on the desired outcome. And essentially, that's what I'm trying to get in this slide. We need to start looking at the mobile network as a part of a business model to create value for M2m and IoT solution providers. At the bottom of the slide, I've kind of tried to draw the distinction between the different words that we use when we talk about value. We talk about, is there a business case? Well, the business case is just a determination of how much value there is to be captured. It doesn't mean you necessarily are able to capture it. You're just trying to estimate what is there for me to get. We talk about the value proposition. The value proposition is normally a discussion about how will I actually create value for some user or some customer of mine. But the key element is the business model, which is how will I capture that value? And I think when you have difficulty monetizing M2m IoT roaming or any other network service, it's because maybe the right business model has not yet been identified. There may be value, there may be ways to create value for customers, but the element of extracting or getting value in return is where the monetization part comes in. And I think a lot of the times this isn't accurately addressed. So with that said, and before I actually explain some of the use cases to maximize that value extraction piece, let's then get in a bit into machine learning. Okay. Now, machine learning for some can be somewhat scary, and there's nothing to be scared about. It's not holistically new. I think the scale and the complexity is new, but the underlying principle, which really is data mining, is not. We've always been looking at huge volumes of data and trying somehow, whether it be Excel sheets or Microsoft databases, whatever tool we've used in the past, to kind of crunch the numbers and get some valuable insight. It's the same thing in machine learning, except here we're trying to automate what we know as human intelligence, or not human intelligence, but human analytical skills in a machine. So if you think about it in summary, machine learning is simply a method of data analysis that automates analytical model building. Okay, so the same way you can build a model in Excel using human analytical capabilities, you're trying to teach a machine to do this itself by iteratively looking at data to come up with new conclusions. Okay, looking for hidden insights without being explicitly told what these insights are or being explicitly programmed to do these things. And I'm trying to abstract this and make it as simple to digest as possible with a diagram on screen. So we look at how a machine can come to a basic decision boundary, which is essentially a way to learn how to classify something, machine learning. And the scenario here is just a taste test. We're trying to understand how we can perhaps decide if someone who has ordered from a menu is a child or an adult. Over time, you will know. So there's something, for example, called label data when we talk about data science, and this is where you know the actual label of the entity. So over time, for example, a restaurant might know that kids often order, treats or desserts that are sweet and cold, and adults tend to order desserts that are warm and more on the savory side. If you feed all this information, all this order information over time, and you put it into the right machine algorithm, the machine at some point may be able to make an assumption or a guess, or as we use in machine learning, a classification based on basic criteria. Was the order for something sweet and cold, or was it for warm and savory? Then it makes a decision, adult or human. This is, again, coming to a basic decision boundary using historical data to kind of find where I can start distinguishing different behaviors. The problem and the real value, the problem occurs when the decision is not so clear or the behavior is not so clearly distinct, and you have a lot of what are called outliers. And this is the second half of the diagram where we start having outlier effect. And this is where the real value of machine learning comes into play. Because you no longer have a clear way of labeling because the behavior isn't close enough or far enough from what you have to be able to make a clear distinction. So you need to actually teach the machine how to resolve this. And here we talk about different types of algorithms, things that are supervised, unsupervised, or reinforced learning. The difference is more technical, but the end result is the same. It's to try to tell a machine or a system how to look at, again, historical behaviors, patterns, and data, and come up with some sort of a label, classification, or a decision. And it doesn't really get more complicated than that. The rest, it is complicated. Actually, let me take that back. It can be pretty complicated and interesting stuff, but that's more on the data science side. From an operator perspective, we just need to appreciate the value of historical data in coming to useful and meaningful decisions. Okay. Now, if you go back to the second part of my previous slide, which is where we had the outlier effect, we now start talking about, okay, what can we implement? And I'll take a traffic scenario, and this is actually going to be one of the use cases I want to share with you. If we take a traffic scenario where one of the fundamental issues, and this is one of them listed in the poll at the beginning, the transparency question. How can you tell when a machine is roaming in your network or not if you don't have transparency between operators? If I don't tell an operator that I'm sending SIMs in machines and they don't tell me, how do we actually detect this in order to, again, measure the size of the business, the growth over time, the types of machines in roaming, the types of use cases being deployed? This is the type of stuff that we don't know. And here's where we actually need to employ different types of machine learning models. Now, one of the things operators can start doing, for example, is start registering all the different data sets they currently have, which would obviously require huge investments in storage capabilities, post-processing capabilities, etc. You can also leverage the capabilities of existing providers that do this for you. But the gist of it is, if you have a clear enough use case and you understand the data that you have, the next logical step is just to understand what would I need to do in order to train a machine, for example, to better make decisions based on its historical data. It's not easy for me to actually see. Okay, I forgot that the questions are at the end. I was checking to see if I may have lost anybody there. But the gist of what I'm trying to explain about machine learning is it's not complicated. At the end of the day, the core or underlying rationale for machine learning is to teach a machine in an autonomous way how to reflect on historical data, understand what the data means, and be able to come up with conclusions or classifications. And we apply this to mobile operator traffic to get as much insights as possible. And it's the merger of the two. It's the merger of this ability to automatically extract insights from historical data and apply it to this network as a service model that I explained in my previous two slides. That will, I think, create the new revenue streams, the new monetization opportunities that operators need to leverage in order to make the best out of M2m and IoT roaming. Okay, there is a distinction to be made, by the way. A lot of people tend to confuse machine learning with artificial intelligence. They're not the same. So whereas, for example, machine learning is about designing an algorithm, for example, that will allow a machine to be able to come to a conclusion on its own without human interaction. When we talk about artificial intelligence, here we're trying to make a machine behave as if it has human intelligence or seem like it has any human intelligence. And we can see the distinction in applications. You may use machine learning, for example, to decide what type of music someone would like on Spotify. Okay? That's just looking at what they listened to in the past and making a decision as to what they may like now. Artificial intelligence, for example, may be a chatbot on Spotify where the user may have an issue. Maybe Spotify isn't working and he sends a message asking for some support, and you now have artificial intelligence providing possible solutions based on the real-time inputs the user is given. I draw the distinction because it becomes an increasingly difficult mountain to climb when we start thinking about applying data science only in the form of artificial intelligence. There are use cases for this, but normally they have to be very specific, and it's very difficult to effectively monetize, especially if you're talking about players at the connectivity level. We're really talking here about just autonomous learning from historical behavior of real patterns and real insights that can help us monetize traffic today, which is very simple when you actually get into it. So hopefully that kind of helps you understand that we're really not talking about artificial intelligence and M2m and IoT roaming for mobile operators. There's definitely space for that, but that's not the topic today. We're looking at machine learning, which is a little bit less complicated. Now, everything I just said can be summarized in this architectural diagram here. When we talk about machine learning, essentially, we're talking about being able to provide a significant and meaningful input to a machine. And significant input here normally speaks to volume and variety. So you need to have a lot of information and it's repetitive so that the machine can actually look and detect patterns and insights. You also need to be able to have an algorithm or an approach to analyzing this traffic in order to make your machine do a prediction. And then it provides an output. This output may be incorrect. You provide feedback, and they get better over time. So if we were to go back to the simple use case of trying to predict if someone was a child or an adult based on their dessert selection, over time, it may start out being an incorrect prediction, but over time it gets better and better because you provide feedback. And that's essentially how machine learning works. So now let's talk about how we put them together, the machine learning capabilities that exist today and the networks that we provide and maintain for users. We need to think, in this case, of machine learning as an asset when we're talking about our business models. If you're only talking about your role as a communications provider or as a mobile operator, you may be thinking, okay, about your radio coverage. You may be talking about the type of throughput that you can provide to your end user, the type of handsets in your market, your global roaming coverage, all the different connectivity pieces. But the thing is, all these different areas of your network, the radio network, the core network, the signaling and data traffic that you send internationally and receive internationally, all this data has a lot to tell as well. And very often, if not true for almost all mobile operators, we don't store, we don't process, we throw this information away. We use it to the extent where it's necessary just to maintain maybe performance. But if you were to ask how much of this information do you actually make use of, it becomes a little bit telling. And I'll give an example. Basic signaling traffic for a mobile operator, you may extract from it the number of SMS messages, the number of registrations, the number of unique roamers. There are a myriad of reporting use cases that today mobile operators focus on. But another use case, for example, and this is where the machine learning comes into play, is there a difference in signaling patterns for example, a roamer who uses data on a regular basis versus one who doesn't? Is there a difference, for example, in the signaling messages, so the technical parameters passed in roaming for a specific type of device? First of all, overlooked and often discarded is where machine learning becomes very important, because a human being is not going to be able to look at all this information and understand, where the relationships are. This is where machine learning comes into play. And you do this by, first of all, embracing data science. I think data science needs to be seen in telecoms as the new norm, as opposed to a strange outlier. We need to use data science to inform high-value use cases. That's the other thing. You need to focus on use cases that go beyond just providing connectivity. As a provider who's enabling connectivity, what other elements of this business could I possibly monetize? Could I focus on the security aspect? Could I use, for example, data science to automatically detect anomalies, either from a security perspective or a quality of service perspective or a performance perspective? And then how can I apply this at scale? So I can do this, for example, at network level. Maybe I can detect anomalies for each of my VLRs or each of my STPs. But what about every single IMSI that I send or receive in a roaming scenario? So essentially, we need to think of how we can apply data science to high-value use cases for the end user, and the end user could be here a person like myself, could be enterprise business, or it could be another mobile operator or roaming partner. So high-value use cases for some end user, and apply this at scale, and then we start talking about monetization, because here you're talking about increasing your relevance, okay? Creating more value for the customers that you serve, having a stronger value proposition, changing the way you differentiate. So we don't now focus only on cost or speed or coverage, but here we're actually talking about differentiating on value. And this has a lot of downstream benefits. I have them here listed, a few of them: higher margins, being seen as a partner in each of the different services you provide as opposed to just a provider, which is another element actually we sometimes need to consider, moving away from the concept of just being a service provider to being a service partner, and all that comes from the value proposition and the strength of it. And I believe machine learning and data science has a strong role to play there. So I skipped a little bit ahead, ahead of myself, George.
Damien, it's time for our second poll question to the audience. So the poll question 2 will be coming up on your screen any second now. The question is, how best can carrier service providers support mobile operators' IoT roaming monetization? And the possible answers are global connectivity, signaling and IPX security, M2m and IoT roaming transparency and analytics, M2m and IoT roaming consultancy, M2m and IoT roaming control, that includes screening. While everyone's voting, I should point out and remind you all that Damien is staying on after his presentation to answer your questions. We've already had several questions in, but I suspect there'll be time for a few more, so your effort won't be wasted, and in any case, we'll answer any questions we don't get to during the session offline afterwards, so do take the opportunity to ask Damien a question while we have him. Great. It looks like things are starting to settle down. So carrier service providers support to mobile operators looks to be very much needed and welcomed in roaming transparency and analytics. Damien, is it the reporting capability that people really want to understand what's being used and how it's being used? So is that what you expected to see in terms of what people want to see from service providers?
George, I will tell you the response is precisely what I expected, and it's because of the nature of the current issue in M2m and IoT roaming. We go back to the beginning, and this is actually why I chose that quote at the beginning. The ability to measure something is extremely important to control and monetize it. And today, we don't have the ability to control or monetize because we have no way of measuring it or to actually be transparent. If you were to think back just a couple of years ago, not so long ago, you could assume that every SIM card that entered a mobile network that was foreign would have been a person. And the question was, are they silent roamers, or are they using billable services, or are they permanent, or are they not? So very simple issues. Today, this assumption does not apply. In fact, if you look at your typical reporting as an operator, let's say, for example, your silent roamer report. Okay, today I can look at all the roamers in my network as a visited network, for example, and say I have X percentage who are using services, voice, SMS, data, and Y% who are not. The question is, okay, which one of these are machines? And is it normal that they're not using data? Transparency is a key issue. And actually, this informs my very first use case that we're going to go through next. It is extremely important, well, until every operator has a commercial arrangement that enforces transparency, and there are different methods like specific APNs, specific IMSI ranges, specific MCC, MNC digits. There are different ways of doing this, but until this becomes a norm in the industry, the question of transparency is going to be a huge problem, because you don't know what percentage of your roaming traffic then is going to be machines or things in roaming. You don't know how they contribute or not to your bottom line, and you have no way of treating them differently from every other roamer. So I am actually perfectly happy to see this type of response.
Great, excellent.
It's in line with the facts.
Thank you, Damien. I'll hand back to you now. We'll close off this poll, and you can get into the use case.
Okay. So, like the poll just suggested, transparency is a major problem, and it's actually a fundamental use case that BICS is working to help solve, and I've chosen it as the primary use case for our webinar today. Now, everyone, I think, on the call is familiar with the complexity of determining whether or not, especially on the inbound roaming side. So if you're a home operator providing connectivity service to some M2m IoT solution provider, and all you're helping them do is to have global coverage, it's fairly straightforward to know that they're machines because you're the one providing the SIM cards or the eSIMs or whatever part you play as the home operator. You have some understanding. But in a roaming scenario, the home operator is not the one responsible for the connectivity, the life cycle of the device. This is actually the burden borne by the business operator. So you put a SIM in a truck, for example, that may be shipped from one country to the next, country A to country B. The operators in country B are the ones who actually provide the network, the connectivity, everything that truck may need in country B. But they were not part necessarily of the value proposition. They were not part of the use case that was being created. They were not part of the design of the solution. A lot of layers have already gone without the involvement of the player who actually provides the connectivity, if you understand what I'm saying. And so for these people, understanding that machines are in their network and what the machines are doing and how many of them are in the network is extremely vital, but doesn't exist today. In the current use case, we have applied machine learning and data science in general to the problem by trying to identify, just from the characteristics of roamers, whether or not they're a human or a machine. And I say the characteristics because there are telling elements in traffic that you can use to determine this. You can look, for example, at the IMEI information, which is passed in some transactions. So this is telling you which specific device it's linked to. And you may have business rules to say that a device that is classified as a modem or a specific type of module is a machine. But if you see a smartphone, it's a human. But then you have the conundrum of machines behaving like human, so using voice, SMS, data, and all the other stuff. And humans behaving like machines, doing nothing, staying in the network, but inactive, not moving in terms of mobility. So that's the first conundrum. The second problem is not every device generates the variety of traffic necessary to classify. So in our research, we found that almost 40% of global traffic, and it's important to point out here that BICS carries somewhere between 25 to 30% of the world's signaling traffic. So a huge percentage of the global signaling traffic passes through the BICS network. And roughly 40% of this was just devices that only produced SS7, so no LTE diameter, no GTP or S8 or GP transactions, so no user plane for GTPU, no control plane for GTPC, just simple authentication and registration related information. And if you only have that information, there's almost no way to apply business rules to determine if they're humans or machines, and this is where machine learning came into play. And the progression on your screen shows us our progression. So in the beginning, we tried to use very complex and detailed business rules to classify roamers that we see as humans or machines, and as you can see here, we had some success. Where in blue, we classified as machines, yellow, we classified as humans, and gray, we just don't know. The color indication is certainty. So if it's blue, it means we're certain it's a machine. If it's yellow, we're certain it's a human. If it's gray, as I said before, we don't know. So with the most complex set of business rules that we could come up with, that we fed into our machine, we had at best, I think it was something along the lines of 45% accuracy in our predictions. So then we took it a step further. Let's apply machine learning techniques and allow it to learn over time. So then we decided to spend a year. We've been applying a year's worth of research on our global traffic to allow this machine to look at everything that humans and machines are doing, providing labels, of course. So for example, we would need to have given a large enough data set that we know to be machines based on different criteria to our model to know what machines behave like across different use cases and different device types and different applications. And the same thing for humans, different type of humans, so social media heavy people, people who only make voice calls, people who do nothing. So a huge data set of both machines and humans in roaming over the course of a year across billions and billions of transaction types until this machine learning model learned at a very low technical level. So here we're talking about extremely technically small details in basic signaling traffic, how to tell if it's a human or machine. And we ended up with the rightmost graph. So on the extreme right, you see that we now have something along the lines of a 98% accuracy. Actually, today, with only SS7 traffic, meaning we're not talking usage, we don't look necessarily on the use of data applications, WhatsApp, Facebook, whatever. We don't look at the device information. So just with basic SS7 related data, we have a 95% accuracy on classifying a human or a machine. And with LTE and data, GRX, IPX data information, we have 98% accuracy. So now we have a way of solving the transparency question. And this is going to be a fundamental point for mobile operators, because whether or not there's transparency between mobile operators, as long as you have the traffic, you can now flag a roamer as belonging to machine type communication or human type communication, and then monitor them separately. So the first use case here is solving the transparency question with machine learning, as you can see here. Just to give a snapshot of what is now possible now that you solve the transparency problem, because you can now clearly distinguish humans from machines, you can also monitor them separately. You can deliver different quality of service to them separately, but you can also focus on, for example, the machines to understand the business. What are the devices coming in? If you don't know the devices, what are the different behaviors for unknown devices? Are they voice heavy? Are they SMS heavy? Are they data heavy? How are they distributed? Are they coming all from one country or one region? Are they coming from a different subset of roaming partners? Do the machines who use voice, for example, also generate a lot of signaling activity on the SS7 network? Do the ones who create a lot of signaling activity on the SS7 network generate any usage at all? You now have the ability to measure and hopefully at some point control what machines are doing in your network. And this applies to the outbound side as well, because not every mobile operator knows what their SIM card is in. So the focus here, or the main benefactor of the transparency solution, would be the inbound operator for sure. But as an outbound operator, you don't always know that your SIM is being used for these type of solutions. It's good as well to be able to see what your footprint in terms of M2m and IoT roaming is on the outbound side. So that's case number one, solving the transparency problem using data science, as BICS has been working on for the past year. Now, there are other use cases once you've solved the primary issue of transparency. And those were the other ones that were also listed. The valuable use case question, for example. The use cases are complicated today because you don't have transparency, but once you can identify a machine separate from a human, then there's a whole world of possibilities now. And we talk about here, for example, like dynamic pricing. If you think about a scenario where you may have an outage, let's say we have, I don't know, a hurricane or an earthquake, for whatever reason, your network capacity is reduced. Do you want to give the same priority in terms of access to limited network capabilities to humans and machines? You may or you may not. This is a question for you to answer in your business model. But if you do you want to put a price on that? So similar to how Uber, for example, applies what is called surge pricing. If the demand is high and the available taxes are low, then I will give the user the opportunity to pay me a higher premium, a surge price. In scenarios like that, when you can clearly distinguish who is who, we may see the concept of surge pricing when limited resources are available at a network level coming into play as a new business model. We may also start looking at things like maybe registration throttling. So again, where you have congestion, you are providing access to your network. And it's key to always remember when I'm talking about these use cases that your network is a service, so the network as a service concept. Yes, you want to provide coverage and connectivity, but you can also think of this as a service. And if the demand is higher than what's available, you may actually take decisions to properly monetize that. Maybe throttling during the day when you want to prioritize people who may use or consume more services that you generate more revenue from, and then so you throttle out the machines. And then you can also prioritize machines maybe at off-peak periods at night when the people are asleep and the machines can go along. It's just the idea of leveraging, first of all, the transparency that you now have and applying it to existing business models to see how I can actually create new revenue generating opportunities. Okay, so there's a lot to it. I mean, people tend to look at different layers in M2m IoT for new value propositions without first exploring whether or not they've maximized the value potential at just the connectivity layer by applying advanced analytics and data science to existing traffic scenarios. Hopefully the use case was useful and clear. If not, I'm sure I'll get the questions in the question and answer section. But on my side, just to wrap up, BICS is in the industry to work with our customers to create as much value as possible. We have seen how we can turn a lot of the data assets that we previously didn't really apply value to into new value generating tools and services, and we're happy to work with mobile operators to show and help them do the same. For me, that's it. So I'll hand it back over to you, George.
That's great, Damien. Thank you very much. We've only got about 5 minutes left, unfortunately, but we'll try and get through as many questions as we can in the time. So the first question, without further delay, how can we get started with machine learning and data science in general, given that this is not an operator's core competency?
This is a great question. The first thing is to just commit to the idea. You don't need a big team. You need a few key pieces. You need to have a data scientist, a data engineer, and an innovative product manager who can actually help you see the value propositions. That's 3 people. You don't have to think about a whole new division or a whole new department, because what you want in the beginning is to be able to fail fast. So take on a very agile methodology. Think about try new things as quickly as possible in the most efficient and flexible way. If it works, awesome. If it doesn't work, that's fine. We learn through our failures. So a very small team. Get yourself 1 data scientist, 1 data engineer. If you are making applications, maybe you want to think about a developer for front-end applications, but data scientist, data engineer, and a product manager who understands how we can achieve value.
Great, thank you, Damien. Next question that's come in is, what other use case examples are there for machine learning and roaming IoT devices?
So the application of machine learning and data science in general is huge. Okay, I focus today on the connectivity layer because for mobile operators, this is where they sit, and this is where their most valuable assets are. And we can look outside of this layer into, for example, the system layer. We can look, for example, in the actual devices themselves. We can talk about, for example, how we can help with the data processing or the computational layer to generate the type of insights. But first, I would say make the most of the networks you currently have today and that you've invested so much in before we start looking at the different layers. This has just been my perspective. Now, in terms of other use cases, I think I've gone through 3 just now. So solving transparency, the application of differentiated pricing by communication type, so machine versus human, the prioritization of access to the network, because you can now distinguish humans and machines, you can also monetize priority. But there's also security. Not every M2m and IoT application will require the same level of security or reliability or even speeds, for example. We focus a lot on the speeds, so the data rates, but we forget also the other elements I mentioned to you before. If I were to just go back to my list, if you remember, I mentioned to you that there's also the coverage, the performance, the security, the reliability, the priority, and the transparency. And I just wanted to go back to that because those are elements for use cases as well. If you talk about network priority, if we go back to a congested situation, if you can automatically scale your network using machine learning algorithms on demand. So, for example, either opening up additional capacity that you may have reserved for failover scenarios, or ordering additional capacity from your service providers automatically because you see the behavior of the network, then you can actually, again, enable continuous and reliable access to networks without impacting anyone, but being able to monetize it by applying dynamic pricing, for example. In terms of security, if you think about a truck that's a part of a fleet management solution versus a pacemaker versus a parking meter, for example. The level of security required is very different. And using machine learning, and specifically using machine learning to detect anomalies, is one way that you can actually monetize the signaling security component of networks. If you can provide as an add-on service the ability to automatically detect attempts to hack or attempts to spoof your devices or attempts to extract location information from sensitive device types or device categories and provide this as a service, that's another way to monetize an existing network. You're not doing anything different. You're actually just scrutinizing your traffic to a much higher degree to provide a new service and creating a new revenue stream. So there are a lot of applications and use cases. It depends on what as a network provider you're looking at, and most importantly, no use case will work unless you clearly understand the desired outcome of the solution provider. We need to make sure as mobile operators that you're talking to these M2m and IoT solution providers, understand what they're trying to achieve. Because they will talk about costs. We talk a lot about keeping the costs low, but sometimes higher costs are okay if the desired outcome is achieved.
Great, thank you, Damien. I'm afraid we're going to have to leave it there because we're running out of time, but I'll certainly be taking away two key messages. One is just don't be scared of machine learning, and the other is that data science is the new normal. I think that's very interesting for me. So thank you very much, Damien Rose from BICS, and also to the audience for your attention and participation. I look forward to welcoming you again to a Vanilla Plus webinar in the future, and hope you enjoy the rest of your day. Thanks again, and goodbye.
Thank you, everyone. Bye-bye.